So I want to do one more example of word problems. I do the whole word problems. This is 3, 4, 3, because they're tricky. These are probably the trickiest ones we're going to see this section, right? Are the word problems with this sort of thing. The biggest question I've been asked so far, and probably the hardest thing to keep straight, is what's your x and what's your y, right? What am I using for x? What am I using for y? Don't you guys wish you were doing this again? What a day my days are. All right. No, I did not. So we have a state's population is growing at 20,000 in 2005. Year I graduated, and it has that many in 2022. Write an equation for the population. The for the is going to be your y. You know what I mean? Anytime we want to write an equation for the number of plants grown, that's going to be your y in the equation. You want to write an equation for the number of grants, I don't remember, but like for the number of something, that's going to be your y. Because that is equal to something, right? The equation is in terms of this. Also, be careful. If this happens to you on the homework anywhere, there is a question that if you use a capital P instead of a lowercase p, it will mark you wrong. If that happens to you, email me. I can actually fix it because it's worth like a good amount of points, actually, that question is. So if that happens to you, a capital lowercase, email me and I can fix it. Okay? First. Oh, it's up here. So this is going to be my y. I'm going to treat this like y, but at the end, that's a capital P. Someone put in a capital P. So y is in terms of x. Input, output, that's my relation. Okay? All right, let's do this. It tells me years after 2005. Remember, whenever I'm dealing with years, pay attention to what they want. Because if it's years after 2005, how many years after 2005 is 2005? 0. So I'm going to treat this like 0. And then this is going to be treated like 17. Right? Does that make sense? If it doesn't say this, it's your choice. But I don't think I've ever seen a year problem where it's not like years after when you start. Okay? All right, we're almost there. That's the hard part. So I have 2 points. I have the point 0, 20,132. And I have the point 17, 38. No, I'm sorry. Yeah. All right. Those are my 2 points, right? This is where our system of using commas doesn't make sense. In other countries, some other countries, they don't. They have a lot of commas. So what do I need to find an equation? I need a slope. So I'm going to find my slope. And then my 34,114 minus 20,132 over 17 minus 0. Can I do that in my head? I would take help if you guys could offer me some help. What do you guys get for that topic? What? I got the 17. No help needed there. What do you guys get for the top if you have a calculator? 34,114 minus 20,132. Anyone? Bueller? 13,982. What's that divide out into then? Let's make this, because I'm not going to use that to plug into an equation, right? I'm going to give myself a decimal. What's that going to be? 822.4. So now, before I move forward, let's think about what that means. What is my rate of growth for population every year? 822.4. So I'm trying to put that in meaning. So when we do the linear regression, the slope has meaning, right? That's for every year, 822.4 more are added to the population. People in AP stats might be having flashbacks. Remember, for every, you had to know all your interpretations. That's my slope. Okay? Now I need to make my equation. I wish I had more board space. So I'm going to do y minus y1 equals my slope times x minus x1, right? Oh, because it told me. Yep. It'll tell you when usually, if it doesn't tell you, I would always just use whatever the earliest year is and make that 0. And then when you write your equation, like if you're not doing this on Moodle in real life, I would say this is the equation for every year after whatever. You know what I mean? Because just make your earliest year 0. Because if you don't, the numbers are really big. You know what I mean? You're dealing with a large y-intercept. It's just gross. Would you agree? Let's use the 0 point to plug in so I have a 0 in there. It'll make life a lot easier. Y minus 20,132 equals slope times x minus 0. Yay. Because once I get slope, this problem actually usually ends up being not terrible, right? Because that minus 0 is going to go away. I'm going to add over 20,132 plus. I'm going to give you a hint. Could I have made this equation without doing that whole spiel I just did? What's my y-intercept? When x is 0, right? So did I know that's the y-intercept? Did I know that's the slope? Could I went right to y equals mx plus b? I could have. The only reason I did this is because I just wanted you guys to see that again because there's some of the problems you can't do that with. But that's a good check. Does that match my y-intercept? Yep. That's my slope. Now what would I do? That would be wrong. Wrong. What would I need to do? P equals 822.4 T. Because they want with the right variables, which honestly it seems like cumbersome, but if you take a stats course, like you take stats next year, this is really important because it makes your life easier to know what each variable stands for. You don't have to think about which one's which. So where am I going to plug in time? Into T, right? But now I don't plug in 30, I don't plug in 2030. What do I need to plug into this beast? 25. Because it's 25 years after that. Let's just have a calculator. Someone want to help me out there in the real world? I should live stream this and have people jump on the chat. 40,692. There you go. Sound good? Yeah. Just making sure I hit record. All right, that's it for 4-3. These ones take the most work. This next section isn't going to be as much work. If you guys are okay, I am going to give you some background and some spiel. You don't have to take notes on a lot of it per se, but I just want to kind of give you guys an intro to this. Again, if anyone ends up taking stats, if anyone's still in taking the SAT, this will come up on occasion. All right. Look, there's a bird on this one. Oh, I forgot. I have to go through all this. All right. So first things first is I want you to, you don't have to write down these terms, but I want you to understand or think about it. We are taking scatter plots. Have you guys seen scatter plots? Bunch of dots. Like fun activity we might do next semester is going to be we take shoe size compared to height. We scatter plot it. And when you scatter plot it, you know, you end up with this. What do you think is going to happen as shoe size goes up to height? Does it go up or down? Up. As one goes up, the other goes up. That's a positive association. This isn't going to come up on any homework or anything. I'm just giving you some grassroots, some start to this. Because as one goes up, the other goes up. A negative association is going to be something like as one goes up, the other number goes down. For example, if I start the amount of fishing rods I buy compared to how much money is in my bank account, what happens to the amount of money in my bank account if I keep buying stuff? It goes down. So the more I buy, the less money I have, right? Because if I were to plot that, it'd be downwards, right? Positive slope, negative slope. We're just using different terms because we're using two variables. We're showing an association. I'll show you guys a funny. No association would be a scat. We'll see this again. But if I were to plot two things like number of times I hear 6, 7 in a day compared to number of times I hear someone quote their football coach, there might be no correlation in it, although there might be a correlation. There's probably a big correlation with it. All right. I'll show you guys some crazy correlations in a second. Oh, this is a better example. Positive, negative, none. So this could be average height compared to amount of sleep in a night. That's a no. Can I draw a line through here that makes sense, or do all these lines kind of make sense? Where number of wins, this is for baseball, number of wins compared to payroll. Is there a positive association between payroll and number of wins? Just ask the Dodgers. This is number of wins in baseball compared to number of runs allowed. If you allow, or the more wins you have, usually the less runs you've allowed, right? Negative association. Okay? Sound good? Now, these scatter plots, just when we do stats, if we do a little bit of stats, the book I use, every single thing in it is actual data. So I always find it really neat because this is real data, real data, real data. It is getting older, though. It's from 2016. All right. All right. So that's scatter plots. Oh, I just talked about it. All right. We do not need to describe them. We do not need to describe them. We do need to do this, though. Go back. Slideshow's slow. So when you do a scatter plot and you draw a line in it, okay? So you guys have a picture of a scatter plot on your page, but if you flip over on that 4-4, flip to the part that talks about R. Yep. So what is R? R is correlation, okay? R tells me how strong it is. When I look at this scatter plot, do you think this line is a good predictor? Like, would this line allow me to make predictions based on it, extrapolate? Yeah, this one's good. So instead of me guessing, R is a number that tells me how good a prediction will be based on the data. The better R is, the more accurate my predictions are going to be. So here's some things. This is all in your sheet, but it's good to know. So R is always between -1 and 1. Okay? It's a negative means a negative association. Right? Or you could think a negative is going to have a negative slope. So if the R is negative, the slope of the line is going to be negative. Okay? A positive R means it's going to be a, oh, it says it right here. Never mind. Sorry. But you can write it. All right. So R is greater than 0. So if R is positive, it's positive association. If it's negative, negative association. So I know the slope, right? If I can give you an R, you know the slope. It's always between -1 and 1. It cannot be above 1. Okay? Because that's actually the percent, R squared is the percent accounted for by the LSRL. Don't worry about that. Don't worry about that. The closer you are to 1 or -1, the stronger it is. If it's weak, it's closer to 0. So for this class, you do need to write down this. A 0.75 and above is going to be a strong, good fit. Or a I'll do this, 0.75 and up, and then negative 0.75 and down, right? Because again, closer are to 1. Now, if you are a stats person, you would say actually a linear fit can work up to like 0.5. It's just not as strong. But in here, we're going to denote 0.75 is strong. Sound good? So 0.8, is that a strong correlation? Yeah. 0.5, is that a strong correlation? No. About negative 0.9. Yeah. Okay. So for this class, if we ever ask, we're going to use 0.75 as the benchmark. All right. Let's play a game. Ooh. You guys like to gamble?
Yes.
How much money you got? That's king. All right. So here's what, let's do this. Do I have two people who like to face each other? All right. Who do you want to face against? Who in here wants to take on Mr. K? All right. Mr. M. I have to use fake names. All right. So here's what I want you to do. Look at this. That's a scatter plot. When I look at that, what do you guys think the R is going to be? Go ahead and write down on your notes somewhere. Write down. Lock it in. What do you think? Remember, 1 is perfect, which would mean it's a straight line. You guys can all play along too, because this is actually really good practice for it. What do you guys think it is? Write down, what do you think R is? 0 would be nothing, no correlation. A 1 is perfect. 0.5 is weak.
I'm guessing.
Yep, guess a number between 0 and 1, a decimal. And it's, we know, why do we know it's positive? Because it's going up, right?
I know it.
They told us in front too that it's going to be positive. You guys locked in?
Yeah, sure.
You guys, let me see yours. All right, we have a 0.67 and a 0.76. All right, who should I plug in? Anyone else have a guess? I'll type in 76.
You.
The answer was 0.81.
I was close there.
So that is a strong correlation, right? That's strong.
I don't really care.
All right, does anyone else want to play? Wait, who's, all right, you want to take on a new challenger now? All right, who wants to take on Mr. M? Do it again. Nobody? You just have to write down a number. There's no shame. All right, write down your number on this one. Write down your correlation. We know it's a positive. What do you guys think it is?
Wait. You said 0 is a which?
0 is no association, no correlation. You locked in? 0.3, and we got 0.24. I'm gonna plug in the 0.24. What do we got? It was 0.21.
Come on, brother. Hey, luck runs out, buddy. How's it?
You guys.
I got my luck right here.
All right. Anyone else want to give it a try? Who do you want to take on? The champ?
No. Take on Rogan.
Wait.
Rogan.
Should we do it? If he wins, all the tickets go to the person who wins.
Yeah.
Like it's just, it's a.
No.
You can risk it, or you can drop out.
Okay, well, not against Jonah. I'm not risking.
All right. Anyone want to take on Jonah? Rogan's gonna take on Jonah. Oh, I mean whoever there. All right. Next one. All right. Lock him in. This next one. This does have a correlation. You all can play at home too. You can write down, take a guess, see how you do. You can the board game version of this. More like we're bored. Hey. Lock in. I will say I'm impressed. We haven't lost any life yet. So I've been plugging in one of the guesses, and you have to be within 0.04 in order to stay alive on it. So far, this guy's destroying it. Everyone's been pretty close, though. This guy's locked in. Oh, 0.37.3. I'm gonna plug in.
Very interesting.
I'm gonna plug in 0.35 just to see what it actually is. It was 0.37.
Oh. Ah. Who gets that? Who gets that?
Should we give him 2 for absolutely nailing it? That's pretty good. What do you guys think this one is? Just anyone want to play? Anyone else want to play? 0.86, 0.9. I'm gonna. These are just for fun. I'm gonna guess 0.9. I actually like that guess. 0.89. So does this make sense to you guys? So So one of the homework questions is, given this which graph matches with this correlation? If you see a 0.9, it's going to look more like this. If you see a 0.5, it's going to be a little bit more scattered. What do you guys? Ooh, this one might be. You think 0.58? It actually might. 0.65. Oh, it was close. It was close. All right, are we good on the game? If you guys want to play this, it's called guessthecorrelation.com. It's kind of a big deal. I got 22 right now.
How did you find this game?
Well, I teach statistics. There's actually a bunch of versions of this game you can find.
32.
My high score is 32, it looks like. But I just tried it yesterday for a little bit. I just made up a fake. Buy me a coffee. No. The 2 players not available. I tried. All right.
And he's got his controller. He can play controller.
All right. So I gave you this chart is on the back of that sheet as well if you look at the back of it. So that's a good reminder, a good reference guide for what is a 0, -3.5, -0. So they get stronger as they go, right? It starts at weak. And this also has examples of negatives and positives and negatives, okay? Sound good? All right. Then the only, if you want to know, this is how you calculate your R longhand. Are you guys good? All right. The only other thing I want to talk about is I'm going to show you this later. It's another fun thing we're going to do. Just a reminder that with this, we are showing a correlation, not causation, right? We can only show correlation. The only way to show causation